Okay, guys, this lesson is no figuring out math or anything, but it is important to be able to interpret different graphs. And so we're going to go over a lot of new information. So I'd like for you can take notes on this sheet of paper and use it for your test, or you can also take any other notes in your math journals. So there's a lot of things. Your assignment's going to look basically like this, 4 questions that you have to find a lot of information about each of the graphs. So we're going to just kind of go through this. We need to figure out, we'll have to write if it's linear or nonlinear. We'll have to estimate the intercepts of the graph. That's your x and y. So your x-intercepts and your y-intercepts. Any symmetry, and we'll talk about this, where the function's positive, negative, increasing, and decreasing. And then the x-coordinate of any extrema, we'll talk about it, and the end behavior. So there's a lot of new words here and a lot of new meanings, and this is just to introduce you to the different shapes of the graph and what they mean and how to describe them. So we'll look first at this wholesale t-shirt order. Okay, it's the number of shirts down here in dozens and the total cost. So it looks like the more shirts, the more it costs. So let's start out by answering if it's linear or nonlinear. Linear means a line. Nonlinear means like a curve. Okay, so when I say line, I mean a straight line that goes, a straight line. And then nonlinear would be a curve. So this one here is definitely linear because it's showing, and even if it's only showing part of the graph and you're going to tell me, but I don't know where it goes after that, that's okay. That's okay. You're just going by what the graph, what they show you. Okay, so this one's linear. And I'm going to go ahead and mark this one as nonlinear. See how it curves. Then we might as well go down and look at these. And this one is linear, or I'm sorry, nonlinear. And although this kind of looks straight in some areas, it's not quite exactly straight, so I'm going to classify this as nonlinear as well. All right, let's look at the next thing we need to do. So it says estimate and interpret the intercepts of the graph. You don't need to interpret them. I think you're kind of smart the way it is. So I'm going to just grab a different color for fun and to break it up a little bit. Okay, so the x-intercept is where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. And you can approximate because these are not exact. So we will go the x-intercept it doesn't cross the x-axis. It gets really close here, and it might keep going, but we don't know that, and it doesn't make a whole lot of sense given that it's a real-life shirts and cost graph. So I'm just going to say does not exist. Now you can abbreviate that with DNE, or here is my not mine, but mathematicians, no solution symbol, and you can just write that. Okay. Then we look at the y-intercept, and it looks like, well, I don't know, this is about 100, so it looks like it's intercepting, right around 70 or 60 or whatever you think it is. Now, any reasonable answer between 0 and 100 is absolutely fine. You're not going to get docked for any of that. While we're doing intercepts, let's do the other ones. So this looks like It doesn't cross the x-axis, so x-intercept again is a do not exist or no solution. The y-intercept looks like we cross at about 40, well, 42-ish. We'll just say 42. Does not have to be exact. Okay. We'll go down here and look at the x-intercept. This time we do have an intercept right here, and it looks like it's at 1.75. And then the y-intercept is right about 10. Same with this one. Our x-intercept does not seem to exist. And our y-intercept is probably at 24. All right. Feel free to pause this video if you need to get caught up on writing this down. Then we're going to look at where the function is positive and negative. And we'll do the increasing and decreasing in a bit. But positive and negative. So positive just means where it's above the x-axis. And negative means where it's below the x-axis. So you can see that this graph is just showing it's all above the x because all the y's are positive. There are no negative y's showing. So we're going to say all positive. This one is also all positive. Well, it looks like all of these are all positive, so I will write that in. If you had a graph that went below, you would identify it by the x value. And I'm trying to think how to say that. So I will just find, like, if this one went, we'll say right here, if it went below from here to here. So if it went below from 1.75 to 2.5, I would write that in. I would say negative from, and you can just use your regular English. It doesn't have to be perfect. We will perfect all that in years to come. So from x equals 1.75 to 2.5, if that were the case. And then it wouldn't be all positive. Then we'd say positive from x equals 0 to 1.75. Okay, so I did change that. So realize that when I drew that in, that's when this positive and negative came. I just wanted an example of that. The next thing we're looking at is increasing and decreasing. So increasing is always going to be left to right, and it'll go upwards, that's increasing, and if it goes downwards, that's decreasing, but it's always left to right. So this graph on number 1 here, this is all increasing. This one here, from left to right, it's going down slowly, but it's going down, so it's all, ooh, that's a terrible decreasing. Let's use the one here that I drew in so that we can see it decreases. Well, we'll just say it pretty much just decreases there until here, and then it increases. So you got to write it both. So, and it's from the x. So decreasing from x equals 0 to about, we'll say that blah, 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 2.2. Okay, and then it's increasing from x equals 2.2 to, you can say 2.5, or you can just say to infinity if you want. I'll just say 2.5 because that's what we see. And then this one here is increasing on the whole graph. So from 0 to 20, you can write that in, or you can just say all increasing. All right, then we go to relative extrema. So relative extrema is a point that, it's a turning point in a graph. And I'm just trying to see. Okay, so the graph, I will just kind of drop here. So if you have a graph that goes up and then down, or down and then up, or a whole bunch of times, those are extrema. Okay, this is called a relative max, and this is called a relative min. And you can just say max. We'll just say max and min. Okay, it doesn't have to be a curve. It could be like this. So if this was a graph, then you have a minimum. And here you have a maximum, here you have a minimum. So when they look like this, and there's no turning point, when it doesn't actually turn and change directions, there's no extrema. Okay, so extrema is the general term for min and max. I say min and max. It's there's different kinds. There's relative and absolute minimums and maximums. So extrema is just the general term. But you can write no min and no max, or you can write no extrema, and that covers them both. Here, it's not really a turning point, so I'm going to say no extrema. Now, this one, we have, where I drew in, we have extrema right here, because this is a definite turning point. It's going down and then it's going up. So in this case, I would say that this is well, I'll just say minimum. So it's a minimum, but you have to tell me where the minimum is at. And you have to tell me by the x coordinate. So minimum at x equals 2.2. You are going to see that you're increasing and decreasing, that where it changes, that's going to be either a max or a min. So if you have both increasing and decreasing, that point where it turns is going to be a min or a max. Here, I wouldn't consider any of this any extrema, so I will again write no extrema. And then lastly, we have end behavior of the graph. And end behavior is exactly what it sounds like. So I'm going to use pretty blue. Okay. It's how the graph ends. Okay. So we're talking about on the right side. That's all we care about in this class, is the right side. And all we care about is if it's going up or going down. So if this line continued, is it going to go up forever or down forever? It's going to go up forever. So we are going to say the end behavior is positive infinity, because if it were to keep going, that's where it would go. Okay, so end behavior is going to most likely be positive infinity or negative infinity. Okay, positive infinity is up, negative infinity is down. And there are some cases in which it's a constant line. And even on here, this looks like it's getting closer and closer to this point that y equals 30. Okay? So you can write that if you think that that's going to just kind of keep getting closer and closer to 30 and kind of way it goes. So you can either consider the end behavior as negative infinity or y equals 30, because that would be the horizontal line that it's kind of getting closer to. The end behavior of this graph, the graph that I drew in, I would consider that that's going to keep going up. We really don't know what's going to happen because I just made this up and it probably doesn't make any sense at all. But yeah, let's say that it goes up forever. So this is going to be a positive infinity. If I didn't draw that in and it was just the original where it was going down, I would say negative infinity. But where I drew it in, we're going to go with that. And this one looks, you can interpret this a couple different ways. If you want to say it goes to positive infinity, that's fine. I think it's kind of staying at this line. It looks like it turns a little bit. So I'm going to say y equals whatever that is, 72. So that is kind of a lot of information. Oh, we didn't talk about symmetry. Did I miss that one? I totally missed symmetry. Okay, so symmetry, we need to get that in here. So if it's symmetric, your graph is going to, none of these really look symmetric. So for a graph to be symmetric, you have to be able to draw a vertical line at some point and then fold it, and it's the same graph. Well, if I drew a vertical line here and I folded it, it would not line up. Okay, so no symmetry. This one also doesn't have symmetry because it doesn't matter where I draw the vertical line, it's not going to line up. So I'll say no symmetry. And then I will show you an example of symmetry here in a bit. Neither of these have symmetry either. Now, if we had a graph, and I'm going to just draw on here in this little area, if we had a graph that looked, let's see, I will draw, that's my coordinates, and let's say it looks something like this. Okay, and then these are marked. So let's say this is 5 and this is 10, 0. Okay, it doesn't really matter what the y's are. So in this case, it looks like I can draw a line right here down the center. Oops, that's not the center. Trust me, it's not easy to draw this. Pretend that's in the center. So, and pretend it was drawn symmetric. Okay. So if I can draw a line somewhere, and if I folded it, it would represent, it would match up. The graph would line up. If that's the case, then it would be symmetric. And you would label that by your x's. So symmetric at x equals, and in this case, it's 5. Okay. So I know a lot of these are tricky. You're going to do a worksheet pretty much like this, and I don't have the worksheet on hand, or I'd look at it and try to foresee some issues. But what I want you to do is do the worksheet. You can hand it in if you want, just to hand it in and so you don't lose it. But on Tuesday, before the test, I think what I'll do is kind of go over if you had any questions, because I think the test is going to ask about, I don't remember. You're going to get the review, but I think it's going to ask about symmetry I can't remember, maybe a min and max, not sure. But yeah, so you will have this worksheet to do, and then you'll have that review that will be passed out. And remember, the review is not, you don't have to hand that in. That's for you to learn. So my recommendation, because you should have plenty of time to work, I hope, that you go through it and you can kind of mark ones that you have questions on, and then on Tuesday before lunch, I will go over that with you. Okay. And then I believe we'll just take the test then after lunch. I think that's the best option since I have to be gone. But anyway, good luck. Do your best. Work with each other and see if that helps. And if you are completely lost, just do the parts you know, and then we'll catch you up on Tuesday. So talk to you later. Have a good weekend.